So I'll make a quick video explaining this section 2.7, and particularly we're going to be explaining how to graph quadratic functions, which are parabolas that don't have the a value of 1. And then on the back side of the worksheet that we're working on today, we're going to be describing transformations from the original parent graph to the new parabola, whatever it may be. Anyway, let's begin. We have this worksheet. Which one should I do? Pick one. Number three. Okay, so let's zoom in and do number 3. So we're going to state the vertex, and we should all know by now that the vertex is hk, but you have to think opposite on h and take k for what it is. So that's exactly right, -2, -3. Let's go to -2, -1, 2, 3, and put a dot right there. And then the next thing to state would be the axis of symmetry, which is simply the vertical line that goes right through that vertex. Sorry, it's kind of ugly. Yeah, and to write an equation of any vertical line, it has to be x equals a number, and it's going to be x equals the value that you want it to go through, which is going to be the x value of the vertex. So the axis of symmetry equation is x equals -2. Why do I write this every question? Because there's going to be questions like this on the next quiz and test, where I give you the original equation, and I don't ask you to graph it. I just say write down the equation of the axis of symmetry that will be x equals that h value. But you got to think opposite of what you see. The next part is the pattern, and the pattern I asked you to memorize was 1, 1, 2, 4, 3, 9. And technically, that's for the a value of 1. And if you have any other a value, you could modify the outputs by multiplying the outputs by that new a value. So we know this is opening down because it's negative, but you could have also said, well, I'm going to modify the outputs by that new a value of -1. Okay, the a value of -1, so you can put times -1, times -1, times -1, and you'll have a -1, a -4, and a -9, which simply means that your new modified pattern is 1 to the side and 1 down, then back to the vertex, 2 to the side, 4 down, back to the vertex, 3 to the side, 9 down. But we already knew that. We're never going to actually show this work. We just know that it's opening down. So you could use the pattern 1, 1, 2, 4, 3, 9, but going down instead of up. Anyhow, let's go 1 to the side, 1 down. We're going to put a dot right there. And you go back to the vertex, 2 to the side, 4 down, 1, 2, 3, 4. And then you go back to the vertex 3, 9. So 3, 9, you're way off the graph, so you don't have to actually graph it. So you need more points. You only have half of the parabola. All you have to do is map them over, reflect them over to the other side of the axis of symmetry. That one's 1 unit away, so put a dot there. This one's 2 units away, so go 2 units this way and put a dot right there. And voila, we have our parabola. Arrow, arrow. Perfect. The domain, x equals all real numbers. And a lot of people just say all real numbers, but you have to say x equals because the domain are the x values and the range are the y values. Like I just said, range are the y values, and you don't even need the graph to state the range, okay? We know they're the y values, and the a value will tell you if it's opening up or down. Because it's negative, it's opening down, which means that your range is going to be y is less than or equal to. Now, if it would have been positive, it would have been a greater than or equal to. But because it's negative, it's opening down, so it's less than or equal to. Okay, and less than or equal to what? The k value. Whatever number's out here at the very end of a vertex form quadratic function is going to be the k value that's going to be right here. So y is less than or equal to -3. So it's really easy to come up with the range, even if you don't see the graph, just based off of if it opens up or down. If it's opening up, it's a greater than or equal to. If it's opening down, if it's negative, like it is right here, it's opening down, which makes it a less than or equal to. The k value simply goes right there. But obviously, if you're looking at the graph, it's even easier. You see that it exists at the y value of -3 and below. So that's why it's y is less than or equal to -3. I guess I didn't explain domain. Domain, it's all real numbers because even though it goes down, it does continue to go to the left forever and to the right forever. That's why x equals all real numbers. Let's move on to x-intercepts. So where does this parabola cross the x-axis? Never. It doesn't. So if I ask you for the x-intercepts, you could just say there are none. There are no x-intercepts, right? It does not cross. It is possible for it not to cross the way it does right here. It's also possible for your parabola just to go up, touch it, and then come back down, right? It could have one x-intercept. And it's also very likely to have a couple of parabolas, or to have parabolas that have a couple of x-intercepts. So it could be like right there, and your parabola goes like this, and that has two x-intercepts at the location, in that case, 3 and 5. But in this particular problem, it does not cross. How about that y-intercept? Right here, it's really easy to see the y-intercept. It's at negative 1, 2, 3, 4, 5, 6, 7, negative 7. Okay, so the y-intercept is at negative 7. You could also state it as a coordinate. You could say 0, comma, negative 7. Okay, it'll always have an y-intercept. No matter if it's an absolute value v or a parabola that's a u-shaped curve, it's always going to cross the y-axis at some point. It doesn't matter if it's really narrow or really wide, it's going to cross. So if you do end up with a really narrow parabola, and I ask you for the y-intercept, you're going to have to use the input of 0 to find out where it crosses. So like, for example, let's say I had a parabola right here, and this is like pretty narrow. Let's say it's opening up. And of course, you had the function over here, and I'm looking for the y-intercept, which is going to be way up here somewhere. You would have to simply plug in the input 0 to find out where your coordinate's at. It'll be way up here. So you'd have to input 0. But obviously, this equation doesn't represent this one. I was just giving you an example. Maybe I'll go over one of those. I think number 4 is one of those situations where you can't clearly see the y-intercept right off the bat. So on number 4, again, you're going to find the vertex, which is the location hk. Think opposite on h, take k for what it is. So that's a positive 4, negative 6. Go to positive 1, 2, 3, 4, negative 6, and put a dot right there. And then we draw axis of symmetry, which is going to be the vertical line going right through that vertex. And that will be the equation x equals simply the x value of your vertex, x equals 4. That's how to produce a vertical line with x equals, not y equals. And then after that, we need some points. So I'm going to go to my pattern. Now, the original pattern that we asked you to, or that asked you to memorize is 1, 1, 2, 4, 3, 9. And that was a pattern from the vertex when your a value is 1. However, right here, the a value is 2. And we know that's going to make it narrower, which means we have to modify this pattern. We're going to modify it by the new a value of 2. So with this new a value of 2, I need to multiply the outputs of the pattern, times 2, times 2, times 2, giving us, instead of 1, 1, it's 1, 2. Instead of 4, 2, or instead of 2, 4, it's 2, 8. Instead of 3, 9, it's 3, 18. So once again, the new modified pattern is 1 to the side and 2 up. Then you go back to the vertex 2 to the side and 8 up. Then back to the vertex 3 to the side and 18 up, which you might not use. So we're going to go 1 to the side and 1, and actually 2 up. 1 to the side, 2 up. And put a dot right there. And we go back to the vertex 2 to the side and 8 up. So 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. And last but not least, 3 to the side, 1, 2, 3, 18 up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Forget it. I'm not going to put those. They're too far off the graph. If it's 1 unit away, I'll draw it out there. If it's 2 units away, maybe. This is just too off. It's too far off, so forget it. Let's just map those points over to the other side, right here and right there, and draw your parabola. And yes, it's pretty narrow. Whoops. Give me a second. Arrow, arrow. Okay. So even though it looks like it's going straight up, it never goes straight up. It continues to go out. So at some point, it's going to cross that y-intercept, right? So if I did ask you for the x-intercepts, you're going to give me an approximation. So we're going to put these like squiggly lines instead of equal signs. And where does it look like it crosses the x-axis? A little more than 2, right? Because see, this red dot is at the x value of 2, 2. At the xy value of 2, 2. So it's a little bit more than 2. So maybe like 2.1. Okay. And the other x-intercept, 1, 2, 3, 4, 5, almost 6. So 5.9, 5.8, sure. Now, when we're talking about the y-intercepts, that's where it gets a little more fun, okay? How about the y-intercept? You cannot visually see it. But remember, the graph represents all the solutions. So technically, if I were to say, I want you to input the number 2 into the function, right? Think about that. If I made an XY table over here on the side, and I asked you to input the number 2, you would put in the number 2 into the X and do the math. Think about it. 2 take away 4 is negative 2. Negative 2 to the second power is positive 4. Positive 4 times 2 is 8. 8 take away 6 is 2. So when I plug in a 2, I get out a 2. And that is an answer, the X value of 2, the Y value of 2. But if we go to the location, 2, 2, we already knew that that was a point because of our quick style of graphing, of identifying the vertex, drawing the axis of symmetry, and using the modified pattern. So in other words, if I tell you to plug in 2, it's a waste of time if you already have the graph because you already know the input 2 gives you the output 2. If I told you plug in the input 3, 1, 2, 3, what's your output going to be? Don't waste time doing this. If you plug in 3, where's your output? Negative 4, right? That's a location 3, negative 4, which means the input 3 gives you the output negative 4. What if I asked you for the input of, like, let's say 1, 2, 3, 4, the input of 4? What's the output going to be? Negative 6. If I ask you for the input of 5, what's the output going to be? Negative 4. Input of 6, what's the output going to be? Positive 2, right? So it's a waste of time to actually make an input-output table and actually start plugging in and pulling out answers because you already have your graph. The problem is if I said, what is the input of, let's say, 7, right? Well, the input of 7, it's going to be somewhere up here, and you actually have to plug in 7 to work it out. So if I'm asking you for the y-intercept, here's your y-axis. What is that x value? 0. So you need to plug in 0 to find that y-intercept. This is actually a lesson from Algebra 1. To find the y-intercept, you set x equal to 0 and solve. Okay? So when you set your x equal to 0, you're going to get an answer way up here somewhere. Let's plug in 0 right here. Let's do this in our heads. 0 take away 4 is negative 4. Negative 4 in parentheses to the second power. Negative 4 times negative 4, positive 16. Positive 16 times 2 is 32. And 32 take away 6 is 26. So we know it's going to cross way up here at 0, 26. So what is the y-intercept? You could say y-intercept is 26, or you could give it as a coordinate 0, 26. Does that make sense? Good. Now that skill of finding the y-intercept is going to pop up a lot in the future. So make sure you understand that to find the y-intercept, all you have to do is set x equal to 0 and solve. Plug in 0, because that's where the y-axis is at the x value of 0. Plug in 0, get out an answer. That'll tell you where it crosses the y-axis. Anyway, we have another 4 questions that you guys should do on your own right here. And on Google Classroom, there's a PDF that says entire unit 2.7. It's not a unit, it's a section, entire section 2.7, but I call it unit. And you could scroll down and find the solution so you could double check if you're graphing it right there. But flip this paper over. And on the back side, we have transformations, right? Anybody going to watch a Transformer movie coming out? No? Yeah? Okay. What the heck is a Transformer? If no one's seen those movies before. A robot that changes into a car or a car that changes into a robot, right? So yeah, it's changes, right? So we are going to have transformations of parabolas from the original parent graph to any other graph that we have, right? So I hope we all remember that a transformation, or not transformation, but a parent graph is y equals x squared. And that one had, let me just bring it up. Okay, that's ugly, but you get the idea. A parent graph has the origin, the vertex, the origin 0, 0. And from there you go 1, 1, 2, 4, 3, 9. And you could map it over to the other side and you get that perfect U-shaped curve. It's not too wide, it's not too narrow. That's because the a value is 1. But if you compare it to a different parabola, it may get wider, it may get narrower, It may get reflected over the x-axis. It may open down instead of up, which means reflected over the x-axis. It may have a new vertex, a new HK, so it may get shifted to the left and down, or maybe to the right and up, or maybe to the right and down. So those are all changes from the original parent graph to the new actual graph. And in order to be able to describe those changes, we're going to write them out in sentences. All you have to do is go through these 3 questions, okay? Here it is, the notes. To describe the transformations from the original parent graph to the new graph, we must go through each of these possibilities in this order. So you start with question number 1. Does it get reflected over the x-axis? Reflected over the x-axis, that's a fancy way of saying, does a parabola open down, okay? And how do we know if it opens down? Well, if your a value is negative, then it does get reflected over the x-axis, okay? So if you have a negative a value, you're going to write down it gets reflected over the x-axis. If you don't have a negative a value, you don't mention any reflection over the x-axis because it doesn't open down, it opens up. Then you ask yourself, does it get vertically stretched or compressed, and by what factor? If the a value is closer to 0, a fraction less than 1, then it's called a vertical compression. It's wide. But if the a value is further away from 0, greater than 1, then it's a vertical stretch. The a value of 1, that's a regular U-shaped curve. It's not too wide, not too narrow, right? If you change the a value to become 1/2, then that means that it gets closer to 0, so it gets wider, okay? So we call that a vertical compression. Okay, so if your a value changes to 1/2, it gets wider. It's vertically compressed. It's kind of like if somebody put some weights on my arms, it gets compressed. It's like if somebody's crushing it vertically, right? Now, if I have an a value, here's the a value of 1, regular U-shaped curve, and if they change it to 2, then it gets further away from 0, and it's kind of like if somebody had my hands tied and they stretched me out, right? It's a vertical stretch. So instead of saying it gets wider or narrower, we're going to say it gets vertically stretched or vertically compressed. Yay? Okay, so the fancy words for getting narrower is vertically stretched. The fancy word for getting wider is vertically compressed. Okay. So I hope we understand this second question, right? Does it get vertically stretched or compressed? And then the last part is simply your new vertex. It tells you if it shifts left, right, up, or down. Of course, the left, right is according to H, but think opposite of what you see. And the up or down part's according to K. You take it for what it is, okay? So again, you're going to ask yourself these 3 questions. The first 2 are based on A, on the A value, and the last one's based on the HK. So over here we have some examples. Example 1, and this is how we're going to ask you on your next quiz or test. It says, describe the transformation from f of x to g of x. Remember, f of x and g of x are just names, okay? Where f of x equals x squared, that's the parent graph with the regular U-shaped curve with the origin 0, 0, with the vertex at the origin 0, 0. And g of x is this new parabola, right? So you got to go through the 3 questions over here. Number 1, does it get reflected over the x-axis? Well, is that a negative sign? Yes. So that's the first thing that happens. It gets reflected over the x-axis. You're going to have to write that down. That means that it's opening down. And then you move on to the actual numeric value right here, okay? Now, the number 2, will it make it narrower or wider? Will the number 2 make it narrower or wider? Wider. 2 is further away from 0.
It'll be more narrow.
It'd be more narrow, right? Now, what do we call that? We call that a vertical stretch, okay? So it says it then gets vertically stretched by a factor of 2. If it would have been 3, you'd say vertically stretched by 3. Why do we not say it gets vertically stretched by negative 2? Because we already talked about the negative sign. The negative sign is right here on the first step. It gets reflected over the x-axis, okay? Then it gets vertically stretched by a factor of 2. Now, again, it's a stretch because it's bigger than 1. If it were a fraction, like let's say 1/2, then that wouldn't be a vertical stretch anymore. It'd be a compression. I hope that makes sense. And last but not least, your parent graph originally had the vertex 0, 0, and now we have a new HK, which is technically positive 4 and negative 6. So the last part is talking about the shifts, which is you're going to shift 4 units to the right, because that's really a positive 4, and 6 units down, because you take that for what it is. Shifts 4 units to the right and 6 units down. Make sense?
Yes.
Okay. Next example. Describe the transformations from f of x to g of x, where f of x is the parent graph, f of x equals x squared, and g of x is 1/4 x plus 1. Well, question number 1, does it get reflected over the x-axis? Do you see a negative sign out here in the front?
No.
So you're not going to say that it gets reflected over the x-axis. It opens up, right? Then you move on to question 2. The a value itself, does that cause a vertical stretch or a vertical compression? Vertical stretch or vertical compression? It's as simple as this, guys. So I went to Desmos and I graphed both y equals x squared and graphed y equals 1/2 x squared. Y equals x squared is the parent graph and it's in red. The a value is 1, and that makes total sense because that does have the pattern from the origin 1, 1, 2, 4, and 3, 9. You're going to be off the graph, okay? But if you change that a value from 1 to 1/2, what happens? It got wider. The closer that your a value gets to 0, the wider it's going to get. If you actually got to 0, y equals 0, well, that's going to be a flat line. It's not going to be a curve anymore. Does that make sense? So the closer the a value is to 0, the wider it gets. The further away from 0, if it's greater than 1, it gets narrower, which is a vertical stretch. So, man, maybe I'm making this video too long. So my point here is this a value causes a vertical compression because it gets wider, because it's closer to 0. Okay. So that's the first thing you state. Not that it reflects because it doesn't have a negative. It just gets vertically compressed by a factor of 1/4. And then it gets shifted. The h is really -1, which means it gets shifted 1 unit to the left. So we're going to state these 3 steps, up to these 3 steps. Maybe it's only 2 like that last example. So we have our questions down here. Not our questions, but our new equations. So from the parent graph, f of x, which is equal to x squared, to these new graphs, h of x, q of x, t of x, whatever the other name is, describe the transformations. Which one would you guys like to see? Pick one.
Number 1.
Number 1. So we're going to go through the 3 questions. Does it get reflected over the x-axis? Is the a value negative? No, so you're not going to mention any reflection over the x-axis. Then you move on to the actual a value itself. What is the a value here? 1. So are you going to mention anything about it vertically compressing or vertically stretching? No, because it's going to be the exact width as the parent graph. So the only thing you're going to say is that it gets shifted 2 units to the where? Left or right? To the left. So the only thing that happens is it shifts 2 units to the left. Because you have to think opposite on h. Does that make sense?
Yes.
Okay. Let's take a look at a different one. How about this guy down here? If you look at the 3 questions above, question 1, does it get reflected over the x-axis?
Yes.
Yes, it does. So that's what you're going to write down first. Everybody write down number 1. It gets reflected over the x-axis. And then you go back up to question number 2. Does it get vertically stretched or compressed? No, it doesn't. Because it doesn't have an actual number right here. If there would be a 2 right there, it gets stretched by 2. If it were a 3, it gets stretched by 3. Right? A -3 gets stretched by 3. If there were a 1/2, then it would be vertically compressed by 1/2. So there is no vertical stretch or compression. So then you move on to the 3rd question. Third question is describe the translation. That's just a fancy word for saying shifts. So according to h and k. So what's your h and k here on number 3?
2 units to the right.
Shifts 2 units to the
Left.
yes. 2. Okay, let me write it down completely. Shifts 2 units to the left. And 3 units. 3 units what? Down. Because the k value, you take it for what it is. So this is the left-right shift. This is the up-down shift. let's do one more. Number 3. Down here. Oh yeah, the numbers are messed up. There's like a couple of number 3s, a couple of number 4s. I apologize. I'm doing the one on the bottom left. Step 1 or question 1, does it reflect over the x-axis?
Yes.
Yes, it does, because it has a negative sign. So let's write that down. Then we ask ourselves the second question, does it get vertically stretched or compressed?
Yes. Compressed.
Compressed. Why compressed? Because that is 1/2, which is less than 1. If it were actually 1, it wouldn't get stretched or compressed, but because it's a fraction less than 1, then it gets compressed. Anything closer to 0 is closer to a flat line, which means it gets wider. So we're going to say, answer the question, this gets vertically compressed by 1/2. And for the final question, where does it shift? You got to think of the HK. Think opposite on H, take K for what it is. So it then shifts where? 3 units to the left, because you think opposite of +3, it's a -3, it's 3 units to the left, and 4 up. Now, why 4 up? Because it's a +4. If it would have been a -4, it'd be 4 down. Simple as that, guys. We have described all the transformations. So I would like you to finish this worksheet and go on Google Classroom and check your answers.